Hello, and thanks for tuning in as I continue with my 300 horsepower Beetle build madness. So a lot to achieve in this episode, starting with the reinstallation of the underbody heat shields. That way I can fit my brand new full 3-inch exhaust system. From that point, I'll be building a DIY tube bend prototyping tool. I'll be using that tool to then map out the path from the engine exhaust manifold down to the brand new exhaust pipe. Finally, I'll be back on the Airbox finishing that up, also with the inclusion of a much upgraded cold air intake pipe. So, a lot to do in this episode. Don't forget to like, subscribe and share. Let's go. So here's the exhaust system I'm going to be installing. It's a full 3-inch system front to back for a 1.8T Mark IV Golf. Hoping it'll fit the Beetle, seeing that it's the same chassis and suspension. This is actually what people call the eBay exhaust. I bought this from AliExpress. All up, the exhaust system plus shipping was just under $600. And this is a full turbo back system. I chose the turbo back system because I thought I might need to reuse some of the turbo components. So this part here is from the dump pipe. It goes from the turbo. And then these two extra parts here is what I bought separate to the kit. This was probably about $80. So I wanted to run a catalytic converter. This is a Euro 4, I think, standard, 400 cell. And I also wanted to run a dump pipe because I didn't want to cut the back of the bumper. For how cheap this kit was, the welds are quite good, and it's obviously nice and shiny. Lightweight, as you would expect, stainless steel. But the quality seems pretty good. I'll let you know the difference when I start fitting it up, because that's usually where these things go wrong, but pretty pleased so far. Okay, the one thing to note with this exhaust, you can see the light coming through, so this is a straight through with insulation on the sides, so it's probably going to be pretty loud. We'll see. I'm also using the original exhaust hangers. I've just cleaned them up. Have I mentioned that I need a hoist? So fun number one, the exhaust tip is really close to the back of the bumper, so I might need to chop that to get that to fit. This is the dump pipe, which if I put it as far in as possible, it'll be okay. Okay, so I've cut about 30 mils off the end of the exhaust tip. The dump pipe, because it's full 3-inch, or whatever it is, just slides completely over the top. So I have got some tolerance if I need it. All right, let's try fit this again. So this is one of the exhaust tips provided, and it's one of the others. So if I fitted this on the Beetle, yeah, it'd stick out, I don't know, how far is that? 400 millimeters, which would be kind of funny. dump pipe's not too bad. Would prefer it a bit further back, but that's okay. It's pretty good. So I made a bit of a blunder. This is actually the mount that should go on the very rear of the exhaust box where the tip is. So I don't know if you can see that still. I'm just going to swap that one out off camera. So before I start building the actual dump pipe from the manifold, I've got some PVC pipe here, which I just got from my hardware store. It's noted DN50, but the diameter is actually 56 millimeters, which by a lovely coincidence is actually the internal diameter of this gasket that goes onto the manifold as well. So my plan is to use this plastic pipe to prototype the final down pipes. What I have here is the bend radius and diameters for a 2¼ inch pipe, which is 57 millimeters outside. So what I'm going to do is I'm going to transfer these bends to this pipe so I can use them as a pseudo mandrel bend, which is specific to that pipe diameter. I'm going to actually cut the pipe using a pie cut method. I found this little converter or little program, if you like, on the interwebs. I don't know these guys, but I'll give them a plug because this is a nice little app. So basically you just enter the inputs here and it'll give you what's required to achieve the pipe radius based on the diameter of the pipe and the bend that you want. So I can actually reduce the number of pie slices if I want, and you can see here that it's reduced the number of cuts, but it has made it more polygon shape. Draw a horizontal line on both sides of the pipe, which goes exactly through the center of the pipe. That way when the pieces are cut, I can align them correctly, because if they're slightly out of kilter, then that actually represents a cut and re-weld on the actual metal bend. So what I'm doing here is I'm just tracing the circle off the end of the pipe and then just trying to find the center of the pipe. So just going to roughly measure middle, one direction, middle, the other direction, 22, and that'll give me the center. I'm just going to draw one 90 degrees to the other. Not that I need it, but just in case. You could easily draw this in CAD or something. This is just a quick way to do it because I don't have the computer in front of me. So from this point now, I can mark at least on one side of the pipe a line which goes through the center of the hose. It goes through the center of the pipe. All right. So now that I've marked one end, place one of the marks directly on the bench and then hold that so that's the only point on the bench, and then use my eyeballs to mark that exact same point on the pipe, which is easier said than done. From that point, I can then mark the other tangent. With both ends marked, so now I'm going to cut where those marks are just a little bit. You don't have to cut them both at the same time. One there. One there. All right. So next, get a piece of string. Just put one end in the slot you've cut. There we go, like that. And then just straight up pull it to the other slot. So I've got that in place. I just hook it into the slot on the other side. There we go. A little bit of tension. I'm going to use tape. So basically just run some tape on both ends so that the tape follows the line. Put a bit of tension on the tape as well. You see here it's making a straight line. Just dump the tape on there. Gently put the tape down. You can take that off now. And now you've got a straight line down one side. And then you can just run your marker using that tape as an edge. Like that. Again, it doesn't matter if you run out on this side because the edge will be absolutely straight if you're running it up against the tape. Take the tape off and you see you've got a nice perfect line. So just so you don't use the wrong side for now, just mark it with something that tells you that that's the good side. And repeat the process for the other side. So building these downpipes is going to be an exhaustive process. See what I did there? I'm not going to necessarily trust the angle that's shown here. I've actually got this from my old college days. I'm going to set up the blade so it's actually as close as I can get to 11.3 degrees, and then I'll do my cuts from there. The other thing what I'm going to do is this line here. I'm just going to line up with the top of this bar here, and then I'm going to number every piece that I cut so that it'll be connected to its adjacent partner. That way, if this line runs out, it really doesn't matter as long as I'm connecting the correct side to each other. So it's 11 degrees spot on. To be quite honest, getting the 11.3 is going to be nigh on impossible, so I'm pretty happy with that. So this is the way I cut my first cut. So if I cut my second cut using this line and the same point on the gauge, I will get the V. What I really need is a middle dimension, because then I can line the blade up. So there's the pi long side, which is there, 54. And there is the pi short side, which is 31.4, which is the bottom. So in order to find the middle, I just take that number, add them together, and then divide it by 2. 44.2 is the middle distance. 44.2, 44. All right. So that is now my cut line. So now that I've cut my first segment out and I'm happy with the angle, I've marked a portion on the gate. Now all I have to do is just bring the pipe to that tape line, cut, rotate, cut, rotate. So from this point on, it'll kind of be production line. So now that I'm all set up, it's only taken me about 5 minutes to produce a bend, a 90-degree bend. Now, the beauty of the pie cuts is that if I need a bend that's not quite 90 degrees, each bend being, in this case, 11 degrees, I can take that out, and that simulates cutting a mandrel bend. So obviously with the numbers of pipes, I can combine them as I need to and rotate them as I need to. And that is a good analog for building my pipes. The exhaust manifold actually sits underneath this area here. I'm not going to take any of this off just yet because this has all got brand new gaskets and torque down. So I prefer not to have to replace all those again. So I'm going to work from the bottom. So this is the reason why I decided to fit the exhaust first, because I actually need to know the axis of the exhaust so that I can bring the dump pipe from wherever it's coming and align to this point. So there's the two outlets from the factory exhaust manifold. So I've got a short length of pipe here, and I've just taped the exhaust flange gasket to it. So I'm just going to pop that in and see where it lies. So, all right, so that's pretty good. Probably need to shorten that up, and then feeding it onto the other one. Yeah, the other one's got stuff in the way, so let's have a quick look anyway. So I also need to add the bellow, the flexible bellow. So I need to add that into my calculation. So what I'll do is I'll just use some of this straight pipe to simulate the bellow length, and then I'll start my curves from that point. So after a few hours, I've got the first dump pipe done. There are 2 banks on this, so I've left enough room so that the second pipe can fit in next to it. So I've got a slight bend at the top, straight to simulate the bellow, and then a bend with, or a complex bend here. So I'll start working on the second down pipe. And I've also made sure that I'm clear of the drive shaft. So here's a finished product, if you will call it that. So it doesn't look the prettiest, but it gives me all the information I need to know. So tracing these lines, I can see here, this goes off center, so there's a twist there. I can see there's a twist here. The sleeve was good because it allowed me to put the bottom in place and then map this long piece without having to go back and forward cutting slices out. I'm pretty happy with my dodgy exhaust prototyping tool. The other nice thing is that I can keep these. I don't have to throw these away, so that if I ever make an exhaust again, I've still got these cuts that I can prototype again with. The flanges to the R36 are not any conventional flange shape or size. I've actually traced the R36 gasket and entered it into CAD. So with this file, I'll send this to the laser metal cutting company and then get them to cut me 2 flanges out. So what I'll do is I'll run through the assembly of the airbox using my modified adapter here. So again, this is 3D printed. I gave the link in a previous episode. I'll leave that on the screen. All right, so the first thing to do, which unfortunately I did that off camera before I started filming from the YouTube channel, but you need to cut the hole to suit the adapter. Okay, so this is the outside, the highly rounded area. So to initially cut the hole, just use this as a template. So you've got this inner ring here, so I would start with that and just slowly cut the material until you get the correct shape. Now, a couple of things to bear in mind is that this area here, I had to use a soldering iron or a hot iron just to bend the plastic to get it to conform to a uniform shape, rather than build the adapter to an awkward shape that wouldn't slot in easily. So the other thing as well, this needs to be printed from ABS or some high temperature plastic so that it won't deform under the heat of the engine bay. Also, what I've done here is I've put in some brass threaded inserts. This side is for the MAF. This side is to just give a mechanical key for the horn that's on the inside. So you'll end up with these 2 screws being the locator for the MAF. Going to the inside, so the bolt holes are asymmetric. You can't really see it here, but they only go in one direction. The print actually has an arrow, and the other side has an arrow, which is a bit hard to see here, but you will see it on the 3D model. So with that in place, the arrows just line up, and you'll see that there's a ridge inside there. There's a lip here, so that'll form the seal. The other thing to note here also is that there is a ridge inside the outer ring. That's to allow for the original O-ring. All right, so the next stage is essentially gluing. Now you can use epoxy. I like this stuff because it's oil resistant and it will cover some of the areas where there's a little bit of a gap. So I'm just going to go ahead and glue it. So I let the sealant dry overnight. The adapter's all nice and solid now. I've just screwed on the airflow sensor. I haven't inserted the seal for the sensor because I've got to pull this apart again because I want to paint all of the plastics in the engine bay to match. So I installed the airbox, sitting there in its correct location because obviously it was the stock Beetle one to start with. Correctly fitted up now the main pipe to the inlet, so everything's nice and cozy. I'm just going to look at the airflow path into the airbox itself. So I've just mocked up the original airflow pipes, and wow, what a cacophony this is. A lot of bends, a lot of restrictions. Also, looking at the port of the end, yeah, it doesn't cut it for me, very small. So after a lot of pondering and looking at different ways I could attack this problem, because it's not a straight path, it actually has to bend around the headlight and all sorts of horrible shapes. And I ended up deciding to go with silicon pipe. So this is a 103 millimeter internal diameter silicon pipe. I just chose this diameter for no particular reason other than I thought it was the biggest that I could fit in this area. So this is the path that I'm looking to achieve. So from the airbox, bend, and then come down to the front behind the bumper. I'll probably turn this a little bit. I still need to make a bell mouth ending for this as well, and I'll print a 3D adapter. So I've just designed and 3D printed this plastic ellipse just so I can work out how to fit this silicone pipe onto the bottom of the airbox. So here's the second version of the intake pipe that goes to the airbox. I've already cut this one. And basically, this one's already been cut previously. So this is going to butt up, something like that, forming this weird angle shape. So my next task is, I bought these rings intended for silicone hoses to join them. So what I'm going to do is I'm just going to try and create this to be an oval so that it matches what's coming out of the filter box itself. I'm also going to use this as a bit of a guide. All right, so after a lot of squashing and bending, I think I've got it. Hard up against there. The light bucket. Go in there. Just some temporary bolts for now. Need one. It's only for alignment purposes. An extension of the port. I can rotate this a little bit as well, which is a nice bonus. All the stainless steel joiners are in. Also, that one there is in. It's a bit rough, but it's in place. I finally got the cold air intake in the position where I'm happy. Fits under the headlight carrier and not too constricted as it finds its way through to the airbox. It's on the limit of the battery, but I'm hoping that should be okay. So now I'm going to go off and design a new adapter for this part here, which won't take me long, and then I'll have to finally print it in ABS. So that'll probably be a week's worth of printing. Okay, so the exhaust went in. It was a pretty straightforward process other than the exhaust tip. My only other comment is that the prongs that go into the mounts are a lot thinner than the OEM ones. So I'll need to put a packer around those prongs so that they don't wobble inside the mounts. The prototyping went really well. I was amazingly surprised how well that went. So that's good to go. I can now order the bends that I need and also the flanges. The airbox, yeah, 3D printing just takes a long time, so I'll be continuing and finishing that up in the next episode. All right, don't forget to like, subscribe, and share with your friends.